We're going to wait another minute or so. There are people coming into the webinar. So just stay tuned. You're not arriving late. You're arriving on time. So I appreciate everyone who's here early as well as those who are arriving promptly. And we'll get going. Everything will be recorded. So okay, I will start now. My name is Paul Siegel. I am with CyberWarrior. I am just going to be a very brief introduction moderator for this. Kevin Cardwell will be running your security program. The Cybersecurity Warrior certification is one of many types of programs we run, and I think you'll enjoy it. I think you'll get a lot out of it, and I certainly hope this is something you find meaningful and helpful in your career. So let me just very, very briefly run through what we do, how we do it, and why we're doing this. We're CyberWarrior. We are a 20-plus-year-old company focused on fintech education as well as wholesale and retail and a myriad of other fields. We do our education for largely large organizations around the world. This includes big banks, big technology companies, government agencies, and the like. Largely, as I said, some of it's cutting-edge technology, some of it's traditional enterprise IT, some is project management, finance and banking, and business skills. The finance and banking are very esoteric courses on derivatives, capital structure, things like that. And the other is, as you can imagine, a series of topics. Hands-on, practitioner-driven. None of this course is by academics who've never had the experience in the field. So what you're going to get is real experience, and you can ask questions and interact, and that's the way this thing runs usually. With a lot of discussion and back and forth, and that's the best way to learn. We do education online, we do it live, we do it in person. We have a recorded library of a few hundred courses, which is useful to you at the end of the day. CyberWarrior Institute is an associated organization which essentially provides these kinds of programs. If anything, our programs are considered difficult, which is fine. They're challenging. We like to challenge people. We feel you get the most out of that from your career point of view. This program summary is a focused cybersecurity program on the key issues in the market today. It's 7 webinars of 45 minutes to 60 minutes. There's plenty of time for Q&A. We'll also have a discussion forum set up online, so you'll be able to access that discussion forum and discuss issues that have been raised. We will record these webinars. They're usually available within 24 hours. You'll get an email from RAND or the help desk, and these are useful for you to review, but also if you miss a webinar or come a few minutes late, don't worry, you'll be able to get access to it. There'll be a very short test at the end of the entire program. So in May sometime, to get your certification, you'll have to answer 25 questions, 70% passing score, and you'll be able to take the test 3 times. So you should be able to pass this. This is not intended to fail people. This is intended to give you the desire to pass and to become a cyber warrior. This will be no cost to you whatsoever, and you'll get a digital certificate. What's this all about? Understanding, providing you the ability to fundamental issues of cybersecurity today, to provide you the tools so you can understand how Wireshark functions, to be able to explain and apply essential cybersecurity defense strategies, to help you build a cyber range, to help you be able to discuss penetration testing and intrusion analysis, as well as appreciate intrusion handling. Here's the program. You can see it on our website. We'll also, again, send this to you regularly, so you don't necessarily need to take it down today. But again, you can add this to your calendar. We have 2 programs this week, 1 next month, and then in May. The reason for this is purely logistics. There's no other secret sauce around it. We'd love to have had it more evenly spread out, but this is the way logistics have worked for us. So again, don't worry about this calendar. We'll get it to you. You'll be able to add these elements to your calendar as well. Kevin will tell you about himself. I won't go through it other than to say here's a real expert in this field. He's got lots and lots of security experience that will be useful both in government and outside. He has authored a lot of courses and material in this area, and so I think you're going to get a great deal out of this. The last thing I will say is, again, for participating in the webinar, whether or not you decide to go on the certificate program or not, which again is cost-free, you'll get access to one of 15 or 17 of our courses, free, lifetime access. All you need to do in the right pane, you'll see a little chat box. Click on that link. Rand has provided that link at the end of this webinar. Click on it. Give us some feedback. Tell us how we did. Tell us what we didn't do right, what you wanted to see improved, or subjects you'd like to see covered. We'll do that. Again, lifetime access, I highly recommend for anyone, even if you're not in FinTech, is this Business and Technical Writing. It's a 5-star course. These are all available on Udemy. Here's the link. Again, pretty easy to remember, but more importantly, go to the right link there. So again, here's some contact names and numbers. I'm going to pass it off to Kevin now. Sorry, I took a few more minutes than usual, but I think you're going to both enjoy this as well as get a lot out of it. So thank you very much. Kevin, take it away.
Okay, thank you, Paul. So hopefully everybody can see my screen. So basically, I created this type of concept in this course because after 25 years of being in the industry and doing professional consulting, security testing, and all that type of thing, what I discovered was many people don't understand the foundation. So what I mean by the foundation is you want to understand what the networks are looking at and what they're doing, because a lot of people are surprised by this, but I'll talk more as the series goes on. The professional security testing process hasn't really changed in 25 years. We still carry out the same process we did when I was doing this in the 90s on U.S. Navy ships. The difference is the targets. So what you have to do is you have to use different techniques and tools to extract information from the targets. But before you can do that, you have to look at the network traffic and see what the actual targets are telling you. So you've got more background there for me. I want to go ahead and get into the material. And again, the internet's there. You can always search online, but we also will have the forum and you can ask me questions there. So what do I mean by security skills foundation? The biggest thing is developing your security skills. There's constant changes, as most of you know if you're working in this industry. How do you maintain that expertise? And the best example I can give of that is if you go to a course, and you go to a 5-day course, and I teach a lot of these, so in that 5-day course you learn a lot of different things. But if you leave that course and you don't continue to do it on your own, a month from then, you're going to have an actual different types of things. So those are the things you want to make sure is that you maintain your expertise, because this data is perishable. And we practice by doing it hands-on. Now we're not going to do a lot of hands-on on this one today because it's the first one. But the key here is this data is perishable. The best analogy I like to do of it is if you go out and you do mathematics or some type of algebra, if you go have to help somebody with that a year after you've done that, how easy is it to do those problems? This is the same thing we have in security. If you're not doing what I best recommendation I give to people, and I got it from one of my college professors, if you're not putting in an hour a day, at least 1 hour, reading something or working with these types of tools, you're going to lose this data. This data is perishable. You have to maintain this skill set. So what are these skill sets that I'm talking about? Mainly TCP IP. Most people understand the application layer. They don't really understand the lower layers. It's the recommended way we analyze events is we look at the network traffic. Now, very few people is going to want to look at the binary, but I want you to be able to read packets at the hexadecimal level. And that's the way we try to understand the packets that's on the wire. Right? This information is essential if you want to go out there and do security, professional pen testing, security testing, those types of things. You have to understand the actual networks and the traffic of the network. Now the importance of this is if I compromise a layer 2, the data link layer, or layer 3, the network layer, all the other layers are compromised above that. So the lower layer that I can attack or compromise as an attacker, the more control I have over the network of the machines. Correspondingly, as a security professional, the more you understand the lower layers, the easier it is to take care of the other layers. And again, most people sit at the application layer and do not look at the network layer. In Unix and Linux, the reason I put that is because most of your tools, everything comes out on the Unix or the Linux side. So if you know how to use these in Unix and Linux, it puts you ahead of the curve. You can't just learn Windows and run Windows types tools if you want to be a security expert. And then finally, virtualizations. And this is mainly so you can develop and build your own test labs. And I've written several books on this. This is because you have to have a test environment to test on. If you go out and test on the internet, that's illegal. Remember, the only difference between you and an ethical hacker and a malicious hacker is permission. You have to maintain that permission. If you don't maintain that permission, you can go to jail. There's plenty of cases out there where people went to jail because they went and tested something they didn't have written authorization and permission to test. So again, you want to build your own test environment to practice your skills. There's another reason to build your test environment. As soon as you get your skill set and you start learning about things that come out in the newest vulnerability or newest attack, you can put it in your test environment and you can see exactly at the network level, again, the reason you learn TCP IP, you can see how at the network level that attack is carried out. So you can learn how to use it in your professional testing if you want, or more importantly, if you're on the defensive side, which the majority of people in the end, they're always on the defensive side. Once you understand how that attack works at the network level, you know how to defend it. And that's the key. We know we can't get perfect defense or perfect security, but I can mitigate the risk of the attacks, and we'll discuss that as the series goes on, and by doing that, I win. Remember, the hacking process, everything follows a step-by-step systematic methodology. If I break any one of those steps, I win. And that's the goal. We can't get perfect security. That's not going to exist with the internet we have today. So what about these security skills? Well, mainly it's command line. We want you to go beyond that GUI. If you're not comfortable on the command line, start practicing. There's a lot of references and resources out there to teach you how to use the command line. There's many powerful tools within Windows. Get familiar with those so you understand Windows from the command line, because most cases, even when you're doing professional pen testing, those types of things, you're going to be in a command line environment, a shell. So you have to understand how to do adding users, stopping firewall services, stopping the antivirus, those types of things. You have to be able to do it all from the command line. And you got to understand basic coding concepts. I meet so many people in the industry and they're like, well, I don't like the code. Well, you may not like the code, but if you want to be above the curve and be one of the best security experts out there, you at least got to understand how coding works. This is because you look at the attacks, you understand the code, that makes you that much better of a security professional, because you can look at the attacks. Well, the first thing I didn't start off in security. I started off in networking, learning routers, switches, firewalls, all those types of things. And then they says, we got this project for, do you want to work with the civilians? And that was actually, I was in the Navy at the time, internet access to ships at sea. But what allowed me to get into security, once we wired ships and we had hackers all really interested in the ships we wired, that's a story for another time. And what we did is, I could look at the code of the attacks. And when I looked at the code of the attacks and I understood the basic coding concepts, I knew immediately how the attack was being carried out, and then I could actually defend against it. Same with the networking. Once I learned how to do protocol analysis, look at the network level, I could actually design my defense, because all your routers, your switches, your firewalls, everything has network level controls that you can do to help mitigate the risk. And then you got to establish a hacking mentality. And again, I'll go back to my days of programming. When I programmed, I just wanted it to work. The hacking mentality is, I want to break it. That's a different mentality, because if you think of it, if you just want to make it work, you're not thinking outside the box, as they say. And hacking mentality is, if I sit down and ask me to enter a data, like say enter my last name, and the guy who's writing the program, he programs it to hold 40 characters. That's a long last name. Most people's not going to have 40 characters. But what if I sit down and I put 10,000 characters into that, what we call buffer, that area of memory? That's the hacking mentality you want. You have to have that as a security expert. You got to get into the offensive mindset. Think like the attacker. There's a lot of different phrases out there for it, but it's true. You have to be able to do that. And finally, you got to be able to build your own test lab environment for the reasons I've already mentioned. Again, the most power on the system is command line. If it's dark for you, you don't like it because it's dark, it's black, it's scary, customize it. Change the colors, the font size, those types of things. There's still a lot of powerful tools there. We've got FTP usually almost on every command line, and TFTP, depending on the version of Windows, no longer is installed by default, so it might be there or not be there. But again, that FTP allows us to transfer files to and from a compromised machine. So again, these are the types of things we want to do. Also, if you're not aware of it, if you're in a Windows actual command line, to display the history, hit the F7 key. If you hit the F7 key, it's like typing history in a Unix or a Linux system. And what it does is it gives you all the history of all the commands you've typed in that command line. So you don't have to actually arrow up to find it. Some of you probably are familiar with the arrows where you can arrow up, find a command, or arrow down and find a command. But you don't have to do that anymore. You can actually display the history by just hitting the F7 command. So that works out very well. So code, again, this is the thing. With Windows, it's pretty easy. You get an installer package, you run the installer and hope it works. If it doesn't work, then yes, it becomes a little more difficult. But Unix and Linux, we have these three main steps. You got /configure, make, install. That'll get you about 90% of the programs coded and compiled that you're going to be probably using on this system. Now the key here is when you get an installer package, how do you know the installer package is not malware? How do you know it's not the latest ransomware? Ransomware continues to spread and proliferate, but it only spreads and proliferate if the user interacts with the actual ransomware. That is, they got to double click. We all know we click, double click, those types of things, right? So the reality is, if you're a security professional, never trust binaries. You have to figure out another method or means to test that binary. Most of your binaries, if you download it from the internet, if it's a legitimate site, will have what's called a hash. Then integrity check. How many of you out there that's listening do you test and check that hash? If you're not testing and checking that hash at home, that's one thing because it's a home computer, right? Probably not as much of a deal. But if you're doing that at work and you're downloading executable code, downloading installers, and you're not testing hashes of those, you're taking a chance that your company is going to get infected by these ransomware. Ransomware works, again, because of the user interaction. So this hash integrity check's been there for many years. Make sure you test the hash of the file if you download it. If it doesn't have a hash capability, you might not want to install that software unless you install it in that test lab and watch and see what takes place. That's another reason to have that test lab. So those of you listening out there, if you're managers and you have people that work for you, make sure they have a test lab. When we set up the first computer emergency response center in the country of Oman, first thing I asked the Deputy General when I went on site, where's your test lab? Here they had this beautiful facility, hundreds of rooms, just gorgeous, beautiful, swipe access, all this other stuff. But guess what? They did not have a test lab. So how are these people that are supposed to analyze for the entire country the intrusions, all these types of events, how are they going to do it if they don't have a test lab? Extremely difficult to do. Make sure you build that test lab. One of the first things I did when I built the Network Operations Security Center for the Navy in the United Kingdom and the first one in Europe, I built a test lab. Yeah, it's difficult. Sometimes management looks at it and says, why are you spending all this money on something that's not even going to be on our production network? The reason for it is because you have to give people an area to test things and practice. If you don't, where are they going to test and practice? They're going to test and practice on your commercial site. Not good. Okay? Again, we said TCP IP. It's the backbone of the internet. The more you know it, the more security expert you'll become. The way I want you to think about this is you got to know it as well as you know the alphabet. The key with TCP IP, it's based on the principle of trust. So think about it. When it was developed in the late 70s, ratified in 1981 was the last time. When it was developed, how big was the internet? Extremely small. We trusted everybody on the internet. But yet here we are 40-some odd years later, and we're still using the same protocol to run the internet. What's the size of the internet today? Huge, giant, right? Who even knows? Because all the Internet of Things, all that type of stuff. So we're running a protocol more than 40 years old on an internet that today is really unmanageable due to the size. Anybody see the problem we have now with security? Because it's still based on that principle of trust. So again, these are the problems we have today. So I'd like to give this slide. It's just a typical security model. I won't spend too much time on it, but the top part of the diagram shows you normal data flow going from a source to a destination or a client to a server. Authentication is one of the types of security models. So each one of these represents a form of the security or a component of the security model, and each one of these components can be attacked. So when you look at authentication, the first attack against authentication is masquerade. When you look at confidentiality, the attack against confidentiality is eavesdropping or interception. And then integrity is taking the data, not only intercepting it, but modifying it. So the threat against integrity is modification. And the threat against availability, denial of service. And we're starting to see a lot of this, a lot of attacks, a lot of enterprise level attacks. Why? Because they just want to prevent you or make it harder to do your job. That's a denial of service. One of the most difficult attacks to prevent is a denial of service, because most of us have revenue or things that's going to be used in our e-commerce, those types of things. We have to have availability. So that availability can always have an attack. And that's why you see denial of service getting more and more popular today, because the service is there. If it's there, it can be attacked. That's something I want you to remember. If it's on the internet, it's accessible on the internet. This is your phone, this is any device you have. That accessibility means it's susceptible to attack. As long as somebody decides to attack you, they're going to be successful into making it more slower or harder to do your job. And that's the goal of the attacks. Now, one component that's not on the security model, but we still talk about today, is once I authenticate, I get onto that network, what's the next step? That next step is authorization. Authorization or the right or permission to access a resource. Think about this. Every time you log into a system, when you log into that system, what's your privilege level? Well, hopefully it's a lower level user privilege level. If you're logging as an administrator and then you're surfing the internet and doing stuff like that, you're giving the attacker an advantage, because now if you click something, you're as an administrator. Once you click that, whatever you click is going to run in the concept of the what privilege you're logged in as. So if you're an administrator, it's going to run in the privilege of an administrator. Extremely concerning, because if it runs in the privilege of an administrator, it has full control of your system. So don't run around on the internet and surf the internet as an administrator, especially at work. So this security posture, won't spend too much time on this, but I want you to understand what a security posture is. It's deciding what you're going to accept the risk of. And this is where organizations have to maintain a security posture. If I deny everything, the paranoid approach, it's not going to work, because we have to provide services. We have a mission need, a business need. We're always going to have to provide services. The other approach is allow everything, promiscuous approach. Well, that's not good, because that means I'm allowing everything. Then the other thing is I'm going to deny the things I know. Right? The problem is, do we ever know everything? With the internet, no, we never know everything. So the main thing is the prudent approach. The prudent approach to security is the one where it says, you know what, I'm going to allow web, I'm going to allow mail, I'm going to allow this, I'm going to allow that. That's all I'm going to allow. And the default statement is deny everything else. So this allows us to mitigate the risk of what we allow in. And this is the key component with your architectures. Once you start developing a defense and you set this up, and we go through the series and talk about essential defensive strategies, I'll show you how to do this. Segmentations. Each segment's going to have services or protocols that have to come into that segment. If you build a security policy based on that, you only have to mitigate the risk on that segment of what you allow in. And this is critical in the networks of today. You have to make sure you only allow in the things that are required and not too much information, because then you're at unmanageable risk. And that's where security posture comes in, because I'm going to allow the 3 or 4 things I need and deny everything else. So those of you listen there, if you do work in the network, or you work with the network team, or your components when you work around the network team, go ask them a question if it's not you, and ask them if they know every segment on their network, what's inbound and outbound. We call this ingress and egress. If they can't answer you what's supposed to be on every segment of their network, they don't understand their network well enough. Extremely important that you understand inbound traffic, outbound traffic. We'll talk about this more in defense, because you don't want to leave everything open 24 hours a day, 7 days a week anymore. Those days are gone. That's the old internet. So the policy is the key to all this. You got to establish and maintain a security policy. The problem is the policy is the foundation that stands on risk. But the problem is most people don't do this as a team. If some of you out there listening, if you've ever had this task, and they tell you, hey Fred, go give us a security policy. You download a great template from the internet, a lot of great templates out there. But the problem is you have to understand what each component or protocol you're going to allow in that prudent policy. Remember, you're going to allow what you need, but how do you know what that protocol does, right? The same thing is, if you just download that template, no 2 organizations have the same requirements with respect to a security policy. So this can be a huge challenge. And it requires detailed knowledge of the risk associated in any services that you have. That is, if you're going to allow a protocol like file transfer protocol, you have to know all the ports that file transfer protocol uses. You have to know the actual software itself. You have to know all these different types of things. And the problem is the moment you accept that protocol, say it's FTP, file transfer protocol, or it's even secure sockets layer, or it's secure shell, you're accepting every vulnerability that software will have in its entire lifetime. And so I tell my clients all the time, they have to understand their risk. As soon as you decide to go out and buy that product, any product you buy comes with software. If it has software, it's susceptible to vulnerabilities. That means you've accepted the vulnerabilities for the entire lifetime of that software. That's the way you got to start thinking about your security, and most people don't. So now let's talk a little bit about TCP IP. TCP IP is the foundation. Again, it was built on an open standard suite of communication protocols. Dr. Vinton Cerf and Robert Kahn, they were tasked with a task, and that was build a communication protocol to communicate around the internet, which again at the time was very small with universities and military government type sites. Right? So when you want to think about this, the communication is between a client and a server in most cases. But what do they use? They use ports. Well, best analogy of a port, it's a door. If a door is open, I can go up to the door that's open and potentially go inside. But what happens is this communication protocol might require some type of credentials like a username password to get to the other side. Right? These clients typically operate on ports greater than 1023 or 1023. We call this ephemeral. It's ephemeral because it's transitory in nature. Right? Servers typically operate on ports less than 1023, which usually we call privileged because you had to have a privileged user to be able to access those. Okay? That's your main protocols. Well, when you start to understand TCP IP, you want to understand IP, TCP, UDP. You want to give all those types of protocols. Why? Because 40 plus years later, we're still using the same network protocols to communicate on the internet every day. Yes, IPv6 is coming, but how long is it going to be here before it gets here? I like to tell everybody I was teaching IPv6 courses in the year 2000 and was telling people IPv6 was coming then, and we're still waiting for it. So again, yeah, it's coming, but how long? So we have two main protocols we like to reference when we're doing our network training, and that's TCP, which is our guaranteed connection-oriented protocol, which got the data and acknowledgement, and UDP, which basically is connectionless. The best analogy is for UDP, we take a letter to the post office all the time and we mail it. If you don't put any guaranteed delivery or receipt tracking on it, it's connectionless and no delivery guarantee. You're relying on somebody else to deliver it. That's the same thing we do with UDP. So UDP has a low overhead, what we call on a network or a network device. Well, how do we identify the services to where the data is delivered? We do that with port numbers. So the most important thing here is the headers. The headers are the way we understand TCP IP. So every header represents specific data to the service that receives it. This determines our protocol behavior. Right? If you want to set up your access, be it routers, switches, firewalls, or anything, these devices usually are reading the headers. So if you can think and imagine that the device has to read the header, as a security expert, you need to be able to read the header as well. Don't just rely on the device. Remember, hackers make a living and feast on the fact that they can trick or fool devices into thinking something is what it isn't. That's where the headers come into play. If they modify or manipulate a header, us as professionals, we have to identify that. So it's critical to understand the structures of these relevant protocol headers. So one of the first things I want you to do, if you haven't done it before, is to get a tool like Wireshark, and we'll talk about those different ones as the series goes on, and start looking at network traffic and practice reading what the network traffic looks like when you do different things, like when you surf the internet, like when you go on your Skype, or when you do any types of protocol. Make sure you understand how that protocol works at the packet level. So here's just a quick representation of headers. So each layer, the data starts off, of course, in the computer. At the application layer, a header is added to it. And then another header is appended to that, the presentation session. I'm not going to go through them all, but you get the idea. And it gets all the way down to the physical layer. Well, what's the physical layer? That's the ones and the zeros, that's the binary. Most of us don't even want to read the binary. We'll read the hexadecimal, which is the data link layer. But again, this is the process of how this works. So the data has all these headers on those, and we have to be able to analyze these. Now, you could analyze it manually with a tool like TCP dump, those types of things, but it's much better to use a tool like Wireshark, and we'll get into those and how to do that. But again, if you don't understand these headers, start looking at them today if you get time. Pull up a tool and start reading those, or look around the internet. There's plenty of places that have courses, and I have a course at the end about Udemy that teaches you how to use Wireshark for this as well. Well, the cool thing is everything wraps inside of it. It's called encapsulation. So the internet protocols are a main type of protocol. Well, TCP, UDP, ICP, whatever we use in the protocol is encapsulated or contained within the actual IP header. So when we look at IP coming up here, you'll see that there's a protocol type. That protocol identifies what's contained within the packet. So this is where we get into being like a hacker. If I modify that and change it, what does the device do? And this is what hacking's all about, modifying it to a different way than intended to see if the designer or the programmer was ready for my design changes, because if they're not, I win. And that's the goal as an attacker. And each layer has a specific function from data to the wire. And that's what you have to understand. When you look at these layers, each one of those headers is identifying what that layer is doing to the network stack, the protocol stack, those types of things. We have to understand that when we validate and verify what's passing through our routers, our firewalls, and those types of devices that we have protected our networks. Again, we need to understand it. So this is what encapsulation looks like. As it goes down the application, it goes down to the presentation header. The data is always encapsulated inside, and the headers are just continually appended on until we get to the physical layer. Again, the physical layer are the ones and the zeros. Now, you're probably thinking, okay, well, this goes down. This is down the stack, as we like to refer to it. Well, what about when it gets to the receiving station, the server? Well, it has to reverse the process and go back up the stack. Now, some of you are probably thinking, oh, yeah, that's called de-encapsulation. Well, that would make too much sense, because in computers, sometimes we use different terms, and that's called demultiplexing. Now, that's performed by the receiving machine. This reverses the encapsulation process. So what happens is this giant frame, we call it a frame, it gets to the receiving machine of all ones and zeros, and then it starts going up that network stack, and it's demultiplexed, and the header is stripped off. First, the frame header stripped off, then the network header stripped off, and it's passed all the way back up till it gets to the application. So logically, whatever happens at the sender happens at the receiver in reverse. So the physical flow is down the network stack and across the device, a switch, a router, whatever you got connecting. And then when it comes back up the stack, it's actually in reverse of the encapsulation process. And that's how this works. So there was showing you the flow of data. The physical flow of data is down the stack. We go across at ones and zeros, and usually we have a device connecting. We don't have the device here in this logical diagram. And then the logical flow of data, is each stack has the same thing. The sender saw is the same thing on the receiver saw. So the application of the sender and application receiver is identical. It has to be for the data to get there and be there in the same form it was sent. Right? So again, these are the types of things as attackers, start thinking in the back of your mind that hacker mentality. That hacker mentality is, I'm going to break one of these steps and see if either your software you got in place or the software that's there at the network level or wherever I've broke it can detect my, well, modification. It's kind of a modification to the network traffic. So how do we analyze this traffic? We use a tool called a protocol analyzer. The best one for most people is Wireshark. It's a nice free open source tool that you can use on Unix or Linux, and it has a lot of abilities. It decodes traffic on the fly, can reconstruct sessions, and analyze virtually any protocol. And this is what we do. We pull it up into a Wireshark tool and we analyze it. This is where you have to get your skill set. Start getting smart on network traffic, those types of things. But get this tool, Wireshark, wireshark.org. Here's the actual URL for you. Get that, download it, install it, start looking at your network traffic. You might find things on your network you don't even know is there, because again, a lot of people have all these home devices, internet things, they love to call them, those types of things, and a lot of attacks are being carried out over those devices. So this is what the header looks like. Now, I'm not going to spend too much time on the headers because we'll cover this in more detail later, but what I want you to understand here, this header is what is contained with all our protocols. So the encapsulated protocol identifies, is this TCP traffic, is it UDP traffic? And the version would be a 4 or it would be a 6 if it's IPv6. And those are the main things to understand here right now. And the source is where it comes from, of course, and the destination where it's going to. Now remember, there's standards for this header. So as a hacker, if I modify this header, does the device or something that's on the network detect the modification? If it doesn't, I win. And that's all the hacker's trying to do, is find a way where I can win and then modify and craft things to see if I can take control of communications on the network. That's what we're doing. So what I want you to focus on, though, is right here, this protocol. This protocol type identifies if it's TCP, UDP, or ICMP. And I won't get into the numbers too much right now, but I'll just give you a preview. If it's TCP traffic, it's a protocol type of 6, decimal 6. If it's ICMP traffic, it's a protocol type of 1. If it's UDP traffic, it's a protocol decimal 17, but it can't have decimal 17 in hexadecimal, so it's represented by an 11 in hexadecimal. And we'll teach you how to do all that as the course progresses. But right now I want you to understand that everything's in the Internet Protocol header. It's encapsulated, and the protocol that's encapsulated is identified by this protocol type. Now this is the TCP header. This is one of the most important headers because, again, TCP is used for most of our connection-oriented traffic. If we need reliable traffic, guaranteed delivery, those types of things, that's TCP. And you see you got a source port where it's coming from and a destination port where it's going to. And the key thing here is the sequence number and the acknowledgement number. Now, early days we used to have what's called TCP hijacking. A lot of famous attacks, TCP hijacking, those types of things. But this sequence number is 32 bits. And most of the predictable sequence numbers has went away. So now we have possible 4 billion combinations. TCP hijacking is very difficult to do on the modern day computers. But if you want to see it in action, you can get an old computer, set it up, and you can actually see it, because the old computers were very easy to detect. And hackers figured it out and did a lot of famous attacks. And if you've ever heard of Kevin Mitnick, his attack was mainly started with a TCP hijacking attack, right? Those types of things. So the key in this one is right here. These are what we call the flags, or the control bits of communication. And there's a lot of different things that people like to say. Another one that some people like to use, you know, you've got different mnemonics. You got all people seem to need data processing for the network layers. This is unskilled attackers pester real security folk, and that's the 6 main flags at TCP. Again, unskilled attackers pester real security folk. That's the one I like to use. But again, I just remember urgent, ACK, push, reset, send, and fin. So these are the key. These flags tell you what's taking place in the TCP header. Urgent means I have a packet that's not designed to be buffered. Send it directly into memory. ACK means acknowledgement of something that you've sent. Push is extremely important because it's a data flag. That means if I see push packets, there's data contained within that packet. A reset means there's an abnormal teardown or a close of a connection, something happened. Send or synchronize means open a connection with me, and it's the first packet you should see in a connection sequence. And the fin or finish is close a connection or a normal close. All right. Now again, this is just the beginning, so we're just getting into this, but you should know them as well as you know your ABCs. So if that was all new to you, start researching and seeing how that works. More importantly, look at it with a tool like Wireshark, and then start playing with it with other tools and see what happens when you do that. So this is where it all works here. So if you look at this, this is Wireshark. So in Wireshark, we have the IP contained, and within this IP we have TCP, and you kind of see how the IP and then contained within that's kind of indented is the protocol contained within, and then you see the flags there. So if you look, and I'll blow that flag section up here in the next slide, you have flags here that are set in this packet. This is the key again to reading the communication. So let's take a look at this in a magnified view. And here's what I want you to look at. It's all in the packet. Everything takes place in the packet. So if you look here, and we don't have time to do a little question survey, we'll do that, maybe add those in the future. So what's wrong with this packet? So if you start looking here, these are the main 6 flags. There's a couple other flags in here, but the main 6 start there with the urgent or the U flag. So when you look at that, if you remember, the urgent means I got data that we don't want you to buffer. We want you to send it directly into memory. And then I got the push, which means I got data. That made sense. But what's the fin flag? The fin flag is a normal close. So when you look at this packet, does anybody realize that I'm telling a packet, I've got data, but I want you to close at the same time? Does that make sense to anybody? It shouldn't make sense to you. We can't close a packet and send data at the same time. This is a crafted packet. In fact, it's using one of the most popular hacking tools out there called Nmap. This is an Xmas scan using the tool Nmap, fin, push, and urgent. And based on how the receiving box or machine or server responds can help us identify what potentially the operating system is of that machine, because we have ways and parameters that the machine should respond by. If it doesn't, then it might point to another type of operating system. So again, that's all part of understanding TCP IP the way we want you to be able to understand it. So now we want to talk about Unix. And everybody says, well, Unix and Linux, kind of the same thing. Well, no, not actually. A lot of people think that, but it's not. So let's take a look at it. Anyway, Unix has been around a long, long time. They said the death of Unix 20 years ago, and we still have it. A lot of iterations, and it's mainly still in high-end systems. Why? Because it can do a lot more throughput, processing power, all that type of stuff. And I won't get into the details of it, of the memory and all that. That's stuff we can talk about in the review section or the comments boards. You can ask me questions if you got those. I still like to teach Unix. Why? Because if you learn Unix, then you can usually use Linux as well, because Linux is a little bit easier to use. It's still one of the main systems on the internet, and as I said, its throughput is unmatched. And it really separates you from the masses, because the more you understand it, many don't understand it. So if you can sit there and set up a Unix machine, I'm not saying Linux, you can set up a Unix machine, that goes a long way for setting up boxes that people can't set up. I actually, when I did a capture the flag, put Unix in front of some of the red teams that was working. These are pen testing teams that I was training, and they had a hard time getting through the Unix machines because they didn't understand the Unix was really on the network because they thought they had Linux. So what about Linux? Well, it was created mainly by a student, but it was derived from Minix. And if you've ever had any computer science courses, you might have in some books, hardware books or computer operating system or network books, written by a guy named Andrew Tannenbaum. And Tannenbaum, what he did is he wrote a book about operating systems. In the back of that operating systems book, he had a CD, yes, a CD, so it's an old operating system book, and that CD had an operating system on it, and that operating system was called Minix. Well, his student, Mr. Volch, the guy who was part of Linux, he was looking at Minix and didn't do everything he wanted it to do. So he took Minix and derived it and became Linux. All right, and it's huge. Linux got a great following. It's great. A lot of branches on it. Really no standard. You got some commercial, some open source, some types of things. If you actually look in the kernel code, you'll still see Minix comments in there. So that's kind of interesting. So what about Linux? Well, the main thing is Unix is what we call designed. It's a set core that designs it. And Linux has grown. The community has grown Linux to amazing capacity. I mean, DreamWorks and places like that, they do entire movies and render them all on Linux clusters, which is quite amazing when you think about the original design of it, right? So a little bit of comparison here. Unix is more tightly integrated, and as I said, there's a core group of developers. Linux, all kinds of external sources help put out Linux. So again, which one do you use? Well, it's, it can be a debate and people like to argue it, those types of things. Here's my recommendation. Unix users normally build software from source. Not all, but if you're in Unix, you're going to build your compile, you're going to do all that type of stuff. In Linux, you always do apt-get install or package-get. You do different things, and you normally disinstall from pre-compiled binaries. So if you do that, remember how I talked about earlier. You have to make sure you do integrity checks. These integrity checks have to make sure that this is not modified when you're doing this. You have also a comparison. So Unix shies away from hacked code. A lot of people like to hack code, do all that type of stuff. That's not Unix. Unix is mainly implementing mature code. Why? Because they want it solid and stable when released. If you really want to actually have fun with the box, go to openbsd.com or openbsd.org, either one will work. Download OpenBSD, install it, and play with that. That's one of the more secure operating systems out there. And if you've got segments where you can't secure them, put some OpenBSD boxes in there, and you can actually do more protection than you can with most other ones. If OpenBSD is a little too difficult for you if you start playing with it, go with FreeBSD. Again, play with some Unix. Don't just stick with Linux. Linux, again, gets code when provided, has released immature code in the past, and has some stability issues. Some of you out there listening to this might have played with Linux because cloud providers, everybody's putting more and more Linux in. If you've had, you've realized that you can actually overload or crash a Linux box. Like a Windows, almost like a Windows box, how you can have an operation crash the box. This is very difficult to do in Unix. To get a kernel panic and really bring down a Unix machine takes a lot of things. So it doesn't really happen that often in Unix world. So what do we say? Users usually academic research-based use Unix. It's difficult to use, a lot of people say, and it's used in a lot of real-time systems because of its high-end architecture capabilities. As I said, we have DreamWorks doing entire actually films now on Linux, so it's now not just a user type environment, but it's more to tinkerers and hackers, and it's easy to use, and that's one of the things that Ubuntu and those types of things have made Linux into more mainstream because they gave it a GUI. They made it more Windows-like, and let's face it, a lot of users out there like to use the GUI. Some of you might too, but if you want to be a security expert and be the best cyber warrior you can be, learn the command line. Command line's power. The more you master it, the more power you have, and that's the goal. So which one do you use? It really depends. Practice and explore. There's lots of different ones out there. Download them. Set them up. We'll talk a little bit about setting up virtualization coming up. In Linux, it's good when starting out. Unix, once you're familiar with Linux, you want to actually get into Unix. And you always use Unix when security is a priority. And that's the key here you want to actually understand. When security is a priority, you probably want to put in Unix. Now you can make Linux with SE Linux, those types of things. You can harden the box, those types of things. But Unix, as I said, OpenBSD. And what I like to let people know is I've got remote sites on different segments around the world running OpenBSD Unix. And to this day, they're running OpenBSD 5-6 years later, and they still are protecting with the OpenBSD firewall. It's called PF. Now, some of you out there might have heard of PF and heard that it's very difficult to use. Well, then you can use the PF Sense, which is a nice little firewall that actually makes sense out of PF, because PF doesn't make any sense. At least that's what the designers say about PF, right? So that's the main thing. The TCP IP, the Unix, Linux. Those are the solid foundation once you understand your security skills, all right? Read, read, read again. If you haven't read a man page, go read man pages. When I train and teach people Linux, Unix, if the man pages are installed, they tell you pretty much everything you need. Anytime you're writing, well, how do I use this tool? How do I use that tool? Look for a man page. If there's a man page, read the man pages. If you can't find a man page on it, go to the internet and read the FAQs, frequently asked questions. Sometimes the tools will install with actual frequently asked questions. So again, these are all things you can do to actually set up your skill set and your knowledge. And then of course we have the most wonderful, well, it's supposed to be information service, but it's a disinformation service because so many people's on it and you can't validate what's on it. But search the internet and start reading about the different softwares, the Unix, the Linux, those types of things. And again, set them up and build your own environment and test the different boxes. That's one of the most important things to do. You want to test these things to make sure they work in your organization. And again, the more knowledge you can get, the more powerful you become. And we're still in the security skills foundation. Don't get on that tool and start playing with that tool until you've seen everything you can about the tool and read it and those types of things. That's the power and will separate you from the masses. So you're probably saying, well, how do we build it? And that's important because how do we build this? The most important way to build this is the next topic, virtualization. Virtualization today makes our life so much easier. I explained to people 20 years ago, a long time ago, we used to do firewall classes. We'd have one server with 20 network sub-interfaces. Why? Because we didn't want to put 20 machines in. So we'd use 20 sub-interfaces so we could set up for the whole classroom, right? But each student would have 4 machines at their desk, a router, switch, all this stuff. So we had all this kit. And I mean, sometimes I'd set up sites like United Nations, NATO, places like that. It'd take 12 hours to set up the network. Virtualization has cut that time to a fraction of what it used to be. And that's the power, and that's why we talk about virtualization. If you're not familiar with it, you need to start getting familiar with it, because this is what you have to do. You have to build your environment. There's plenty of references and resources out there for doing this. So what is virtualization? It eliminates the need for these separate machines. We can emulate pretty much any architecture you desire. Complex networks. Now I'm actually going to show you one of these coming up. And it's a test platform, because I can create and store these multiple images we call snapshots. So what I do with a snapshot is, I do a lot of forensics type stuff. And what I do in a snapshot is, and we'll cover some of this in intrusion analysis and incident response as we get later into the program. What I do in a snapshot is, I infect with ransomware. Yes, I purposely infect my machine with ransomware or malware or whatever it's got. And then I pause it. Why? Because before I infected the machine with ransomware, I took a snapshot. So if I took a snapshot, what that means is I've got a clean state of a machine. So once I get that ransomware infected, I do the analysis, grab the RAM, analyze the RAM, do those types of things for doing the memory analysis. What do I do next? I revert to snapshot. And by reverting to snapshot, I'm back to the original pristine machine, and the ransomware is not infected. So this might give you an idea out there. If you're surfing around the internet and you want to protect yourself, have people do it from virtual machines or containers today, because containers are popular. If you have them do that and you have an actual snapshot or that given state of time image where you can always get back to where you started, which is good engineering sense. As engineers, we always want to get back to where we started. That's how you set up these environments. Then if you do all the surfing around the internet, you just revert to snapshot and you've lost all the malware or anything you picked up. This is how we did with security operations centers, the threat analysis team, the threat response, that type of thing. This is how we have them do their surfing. They surf from a virtual machine that's got a clean state. So if something infects the machine, they just revert to snapshot, infection's gone. These are the powerful things you can do to help protect yourself and mitigate the risk. Because we know, as we said early on, there's no such thing as perfect security. And that's what we want to do here is we want to mitigate the risk. So when we get into the essential defensive strategies, we're going to explain to you how to mitigate these risks using fundamentals of defense. It's sad, but most people don't use fundamentals of defense today. This is how you can test those defense before you put them on your production network. So I'd like to show this diagram. And this diagram is how, when I told you early on, one of the things missing from the CERT that I helped set up in the country of Oman, which today is the top ranked CERT in the Middle East, but what actually happened is they didn't have a test lab, right? So what do you think some of the excuses I get when I tell them we need a test lab? Oh, it's too difficult, too expensive, those types of things. So what I did is I sat down with them and we drew this picture that you're seeing here, roughly on paper first, and then I put it into a diagram form on a slide. And what it is these are the 5 areas, well, 4 areas of the actual CERT, and then the 5th area is the attacker box. So when you look at this, there was 4 areas of the CERT that we needed to emulate: Threat Analysis Center, Response Center, Infrastructure, and Web. So if you look here, I have 4 switches coming off of a firewall. So this is a virtual environment I built to create the actual test lab. So we took one server and we put all this virtual environment on one server that they had, and we created their test lab. Now the problem was they didn't really have space for the test lab, so we put it on a rack where they could roll it in and out of different areas, but you get the idea. And the last thing we put on was the attacker box, right? Okay? And this attacker box was showing the attacks and those types of things. And that's what I'm showing you. You can emulate any type of attack. With these 5 switches, we controlled the entire network architecture for the CERT, and we showed them how to actually build that test lab and protect their environment and test. So when a new attack came out, we put it on the attacker box and we fired it at the resource center or the infrastructure or the web, and we saw what the risk was to each segment. And that's the goal here. Identify the segment to the risk, the most critical risk segment, increase your monitoring, put all your different information on there, and you're good to go. And that's how we'll actually do defense. Now, the next one we'll discuss will be Wireshark, and then after that, we'll do defense. And that brings me to the last slide, so we can open it up for questions. I believe Paul will take back control. Thank you for listening. And that's the last closing slide right there. Paul, go ahead. Take it away.
Thank you very much, Kevin. If you have any questions, I think this is an amazing presentation from my perspective. I'm not the guru in securities that security, obviously, that Kevin is or any of you are, but I'm certainly willing to. I think we need to take some questions now. We'll open it up for a few minutes. Again, this recording will be available. I highly recommend you also look at some of the courses that Kevin has on both Pluralsight as well as Udemy. These are real deep dives. We will be getting, obviously, in the 7 sessions here, we can only cover so much in an hour each, but we will have a forum as well open on the in the certification program. You'll get access to that very shortly. So we'll keep it open for another few minutes if there are any other questions. Kevin, I'll actually ask a question just simply is, what is the most common form of attack these days that big organizations are concerned about?
Well, it's what we call client side. And what it is ransomware. You hear that, but it's mainly a client side. And what that is people have realized that the operating system designers, I mean, anybody out there, if you're working with Server 2012, Server 2016, they're pretty tight. I mean, there are a lot of good things that Microsoft's put in there, those types of things. So it's getting harder to do what we call a server-side attack. So the attackers are going to social engineering client side, what we like to call client side. And what it is send an email saying click here. If people click, or text messages on your phone, click here. So it's what we call client side, and that's where the ransomware is all derived from. It requires client interaction. A user has to click. Now, having said that, we know we cannot stop the users from clicking. What we can do is set up our segments and isolate our segments, and that's why I teach when I train people, especially advanced network defense. Every one of your segments, you put a decoy or a trigger. So anytime malware gets on a device or a box, what it does is it does 2 things. One, it sends out its report out to its handler out on the internet and says I'm in. The second thing it does is look around for its next victim. So if it hits a decoy or trigger that should never receive traffic, that's your indication that that segment has been infected, and then you go into your response phase from that. And we'll teach it as we go through, but absolutely client side, and more popular name is ransomware. And that's just because users get all these emails and they click. I mean, if you get emails that says you got invoices, you got taxes due, all that type of stuff, don't click it. None of that stuff comes via email. Don't open that attachment, because when you do, now you're taking the chance of actually infected ransomware. And like I said, if users are checking their mail and doing stuff like that at work in their administrator account, now they're giving ransomware administrator access to the machine, which even makes it easier, which it doesn't even need that for most cases. But that's the #1 attack, is client side and ransomware.
Okay, excellent. I also encourage you all to give some feedback, because obviously Kevin will be doing this 6 more times and also taking questions and discussions in the discussion forum. So give some feedback on the survey link on the right. It's the SurveyMonkey link, /R/H8Z, I think that's S85. Click on that link, give us some feedback, get access to a free course for lifetime, and also I encourage you to go to Kevin's courses on Udemy and Pluralsight. You can see the links below. Again, this deck will be available to you in recorded format, probably by the end of the day today, but maybe by tomorrow at the latest. And I do greatly appreciate Kevin's contributions, obviously, and your feedback. The best way to learn, my experience, is to interact, ask questions. No question is a silly question, that's for sure. And I know in security people are going to be a little more timid about asking questions, but don't be timid. I think you can see Kevin's a very open guy. He knows this subject backwards and forwards, and more importantly, he's here to help you do your job better. He's here to help you answer the kinds of problems you're going to face in your daily work. I see people from a myriad of types of organizations participating today. You're going to have different challenges. You're going to have different circumstances. They're not all going to be the same for sure. And some will have different points of view, and that's good as well. And we hope to have you participate in the discussion forum. So with that, we'll leave a few minutes early. Thank Kevin for a phenomenal program today. And again, all your feedback is encouraged, welcome, and participation is really a must. That's the best way to learn, the best way to challenge yourself. And we appreciate everyone. Again, you'll get a copy of this recording shortly, and we look forward to your participation in the next program. Thanks, Kevin, once again.